This is 8.5 partial fractions day 1. This is just going to be another strategy that we can use to help us integrate. So if you remember back before the AP exam, we had basic integration, we had U substitution, we also had using the different forms of trig as well, and then also inverse trig, and then we talked about last week using integration by parts. So today we're going to talk about partial fractions. And the basic idea of it is that it is a process to decompose rational functions into simpler rational functions in order to apply basic integration formulas. Okay, so let me kind of show you generally without any variables involved the idea of, let's say for example, 12 over 35. What you want to do is you want to go back and say, okay, well, how could I decompose this fraction? Well, I know that 35 has multiples of 5 times 7. And then what we're trying to do is we're trying to figure out what would the numerators have to be in each of these cases. So that's kind of what our question mark is going to come in. Okay, so we're going to be doing that with actual functions. So these are the steps that you want to take. The first thing is you're going to find your basic equation. Okay. And when you work through this, remember we're going to need to make sure that the numerator should be 1 degree less than the degree of the denominator. You're going to want to find the values of your unknowns. Okay. And then rewrite using your partial fractions decomposition and integrate. So decomposition just means you're breaking it apart, making it simpler, and then go ahead and integrate like normal. Okay, so today we will look at linear factors only. Alright, so here's our problem that we want to integrate. It's going to be the integral of 1 over x squared minus 5x plus 6 dx. Okay, so the first thing we want to do is think about how we could factor the denominator, because we want to set up find our basic equation. I'm going to say, okay, I could factor that. I know it's the same thing as what numbers multiply to 6, add to negative 5. Well, negative 3 and negative 2. Okay. And then we're going to say that it be, well, we're going to let our unknown be in the numerator a. Something over x minus 3 plus something over x minus 2 gave us our original function. Okay. Now to make this a little bit simpler, I don't want to have to deal with fractions, so I'm going to multiply by the LCD, which is x minus 3 and x minus 2. So the basic equation that we're going to end up with is going to be 1 equals a times x minus 2 plus b times x minus 3. Okay, so there's our basic equation. Now we want to figure out what a and b are. So we're going to just solve for our variables. So I'm going to say to solve for a, let's see, we'd want to let x equal 3, because then that would eliminate b. So if we plug in what we know for x, I'm going to get 1 equals 3 minus 2 plus b times 3 minus 3, which you're going to see that gets eliminated. So therefore, a is just going to end up equaling 1. Okay. Next, we want to solve for b. Okay, so when you look at that, how could we get a out of the picture? Well, hopefully you can see that you're going to want to let x equal 2. If we do that, you see that a gets eliminated. We end up with 1. Alright, so now we can actually rewrite it because we have a simpler function to integrate. It's going to be the integral, and a was 1, so 1 over x minus 3, and b was negative 1, so it's going to become minus 1 over x minus 2 dx. And we can see, we could do u substitution. You can also see that this is going to be using ln, so this is going to equal natural log of x minus 3, minus the natural log of x minus 2. It's an indefinite integral for don't forget plus c. That form is fine. If you want to simplify further, you could do so. Okay, so there are the basic ideas of using partial fractions. Okay, let's look at another example. So you have the integral of 1 over x plus 1, x plus 2, okay? And we want to integrate this. It's already factored, so we're going to set up our basic equation. We have an unknown a, unknown b, and I'd recommend that maybe you pause the video and try this on your own and then come back and see if you got to the correct answer. There's my basic equation. I'm going to solve for a, so I'm going to let x equal negative 1. Okay, so a equals 1. I'm going to solve for b, so I'm going to let x equal negative 2. And again, b ends up equaling negative 1. It's not going to always be this easy, but these are just more simple examples for you to work through. So now I can rewrite my function. Go ahead and integrate. It's ln again. And there would be my solution. Okay, so see if you have any questions. There's one other situation that you might run into is when you have repeated linear factors. Okay, so for example, if I gave you the integral, it's 5x squared plus 20x plus 6 all over x cubed plus 2x squared plus x, and note that my denominator is 1 degree more than my numerator. If it was the numerator was 1 degree higher than my denominator, then I would need to use long division to simplify first. But anyways, let's go ahead and try to find my basic equation. So if you factor your denominator, you're going to see that you could take an x out front, which would leave you with x squared plus 2x plus 1, which factors to x plus 1 squared. Okay, so there's the repeated linear factor. What you want to do is you need to have one term for each of those different situations, like a over x plus b over x plus 1, and then also c over x plus 1 squared. Okay, still multiply by your lowest common denominator. Out, so it's just a x plus 1 squared plus b x plus 1, and then plus cx. Alright, so first look for something that would be easy to solve for. So it looks like, let's try to solve for a first. It looks like we want to have let x equal probably feel like x equals 0. It would be pretty easy to solve for a. So it would be 6 equals a, and then the b and c get eliminated. So A is just equal to 6. Let's see, now it's kind of hard to solve for B because it has a common factor, both A and C. So instead what I'm going to do is let's solve for C. Let x equal negative 1. Okay, so if that happens, if I plug in negative 1 for x, A and B will get eliminated, so we'll just be left with negative C. Okay, if I work through this, let's see, it's going to be 5 minus 20, which is negative 15 plus 9, so negative 9 minus equals negative C, so therefore C equals 9. Okay, and at this point we just need to solve for B. So we can choose any x value because we know what A and C are. These are only remaining unknown. So choose one that's easy, one that's near to 0. Let's see, where to use 0, negative 1, so maybe 1. Plug in 1 for x, and we're going to also plug in what we know for A. We don't know what B is. And we know that C is 9. Alright, so we are going to end up with, let's see, it looks like 5 plus 20 plus 6 is 31. 2 squared is 4, so 24. B, let's see, it's going to be plus 2b plus 9. And now it's just a matter of solving for B. So combine like terms. 9 plus 24 is 33. Minus 33 from both sides. So when we solve for B, B equals negative 1. Okay, so now I can rewrite everything, and I can actually integrate it. So it's going to be the integral. A was 6, so if I go back to my original one, it'd be 6 over x. B we said was negative 1, so it's going to be minus. Okay, and then C was 9. And now I can go ahead and integrate this. So it's going to be equal to we have natural log 6 will be up front, so value of 6 minus the natural log of x plus 1. Now note the last term will not use natural logs. You're going to use your u substitution, and so it'll be u to the negative 2 when you integrate it, which will end up turning into u to the negative 1. Okay, so it's going to become minus 9 over x plus 1 to the first power plus c. We can kind of simplify this a little bit, where the 6 out front can be in the exponent, so ln of x to the 6 over x plus 1, and then minus 9 over x plus 1 plus c. Okay, now either of these answers are fine, but obviously the second one's a little bit more simplified. So that is it. It will be the homework under 8.5 for the first day for partial fractions.